Hello guys, welcome to class 13 of Python programming. Today we'll discuss about sets. Sets are the ones we already know in our high school classes. So here if you see, data storage is something that is necessary for every domain in today's world. Python provides different types of data structures to organize our data, and these data structures are essential part of our journey to learn Python. Among all data structures available in Python, some are mutable, some are immutable. In this class, I'll be discussing one of these, that is sets. Sets in Python are data structures that are mutable, iterable, and unordered. When I say unordered, there is no ordering here. You can get in any order. If you print this set 1, 2, 3, 4, what you see here, you can get in any order, not necessarily 1, 2, 3, 4 in that order. You might get 3, then 1, then 2, then 4. So in today's class, we'll learn what is set all about, when to use sets in Python, how do we create sets, the operations like union, intersection, difference of sets, and towards the end, we'll discuss regarding project sets. Let's get started. If you recall, the simple operations in sets, like if you have two elements 1 and 2 here, and 3 4 you can write, then 5 and 6. If you find the union of sets A and B, you will get all the elements, but 3 4 will not be taken twice. So if set A is 1 2 3 4 and set B is 3 4 5 6, if you find the union, you will get all the elements 1 2 3 4 5 6. That is basically union. When you find the intersection here, 1 2 3 4, and then you can write 5 6. Here, when we say intersection, the elements which are common to both the sets, they are 3 and 4, marked in red. Here, 1 2 3 4 5 6. 3 4 are not repeated. Then this is called symmetric difference. When I say symmetric difference, if you see this side is the left hand side, A minus B. Let me write here. This is A minus B, and the next one is B minus A from that side. So if you take the union of A minus B and B minus A, remember here, when you find A minus B, the common elements are not taken. Anyway, you are discarding B elements which are not in A, but also those uh, portions which are common between A and B. Here, if you check the intersection and this one, the difference is here in intersection we take the common, here we don't take the common. So this is symmetric difference. The same thing, whatever we studied in our high school classes, the same concept is here. We get another chance to study Python here. Sorry, sets here in Python. Let's go back to Jupyter. Here, how to create a set. Let me write randomly 10, 20, 30, 50, 40, 70, 50, 1, 2, 3, 4, 5, 6, 7, 8. If you try to print A, you find the ID of A. You can print type of A. There is a problem here. Okay. type. So if you check, I have taken this one. Let me write length of a also. You mark here, there is no ordering. I didn't get 10 as the print out here as my first element. I got 70, see, randomly. 70 I got here. Then 40, 40 is here. Then 10, 10 is here. And if you check here, 1, 2, 3, 4, 5, 6. I have six elements here. How many are here? 1, 2, 3, 4, 5, 6, 7, 8. If you change it to a list, then the number of elements will be 1, 2, 3, 4, 5, 6, 7, 8. However, if you keep it as a set, you see the length here, the last one. Okay, length of pay. We didn't get it here, 6. So it's not 8, it's 6. Because I thought 3 are repeated, 2 are repeated here. I mean, 3 are repeated here, 50, but 50 will be considered 1. Then if you count, the number will be 6 here. So let me write something else. Sets are not ordered. So you can write on order. That is number 1. Then mutable. That is very important. And these are iterables. Iterable property is there. You can run a for loop here. Suppose instead I will run a for loop here. For I in a, print I. If you check again, 1, 2, 3, 4, 5, 6. If you are wondering why 6 elements are here, not here, for I in a, suppose I in a means anything in a, it will start with 10, then 20, then 30, then 40. Then you should get 1, 2, 3, 4, 5, 6, 7, 8, right? But whatever way we see, that way it's not stored. Check it. Although we see these 8 elements and 10 is the first one, then 20 is the second one, 30 is the third one. But if you check here, it's actually this way, stored this way, 1, 2, 3, 4, 5, 6. Although you can run a for loop, but in any case, repetition is not allowed in a set. So the same holds good here as well in Python. Things will not be repeated. Now, before proceeding further, we'll check what are the methods available in Python. So already I named it. Okay, so let me write print directory of A. These are the dunder methods or special methods of Python. We'll be able to discuss some of these once we start object-oriented programming. But for the time being, We'll concentrate on these. Even these are the ones we'll be using frequently. One is add, then clear, copy, difference. I'll discuss two or three of these. Rest you can try whenever you have time. So here, if you want to know about all these one by one, you can take the help of help in Python. You just write help and you check what help you will get here. First of all, if you want to get a new empty set, you have to write this way, set this. Then set iterable. You write any iterable here, you get new set object. This means what? Okay. We can do here. This is our empty set. Okay. Let me print and check here even. Let me print. Yeah, it's an empty set. Okay. Then if you want to know print type, see class set, it's a set. Now the question is, if you start this way, will you get a set? Print. See, it says dictionary. If you write this way, it will be a dictionary, not a set. So unfortunately, you can't write the curly bracket here. Suppose I write A, B, C, D. So when I write this, then this one, then the last is this one. So here I get a dictionary. Here I get a tuple, empty tuple. Here I get a list, empty list. So you get empty list here. You get empty tuple here. You get empty dictionary here. But here there is a problem. Because if you run it, that's fine. But if you check C, C will be dictionary, D will be dictionary. Because the same brackets we use, I've already discussed these two. We are now discussing sets. We'll go to dictionary in the next class. Now coming back to sets here, because they share the same symbol, you have no other way but to write set this way. Remember, see this one. So can you write list this way as well? List, then tuple, then here dict, dict, print, Here you can write semicolon as well. That will work. But that's not a good practice. By chance you write in the same line, which is not allowed. But yeah, if you write a semicolon, then it's allowed. I have 5 here. A, B, C, D. C twice, right? So you cancel this. So this way you can get all. You get a empty list, empty tuple, empty set, empty dictionary. You can check the types also. So these are empty ones. Then one by one, you can append one element here, then the second one, third one, fourth one. Then you can make a full list. Now coming back to this one, sets, this is empty set. Then after getting the empty set, the question is, can you make it whatever you want by adding one by one element? Similar to tuple, is it possible? From empty set, can you get a set you want? Let's check here. We have a method here. If you check discard intersection is the mathematical operation. Then subset is there, superset is there, pop, remove. Some we are not able to see here. Yeah. Add means what? How can you know what is add? This is the directory. So go to the help here. This is also something we have to see. If you are wondering to know what is this, even in my system, it's not 3.8. Yeah, it's 3.7.6. So this is a recent addition actually. This one, this forward slash. This means something. You need not worry. But if you try to operate, even you write a function and you try to write this one, it will not work. It's implemented only from 3.8 onwards, 3.8 Python. So this means whatever you have here, these are positional. Keywords are not allowed. Keywords are not allowed. We'll go to that later. But remember, even I can test this one also. Don't worry about the underscores here. 4 underscores are here. But let's go to the ones we use frequently. Now, when you use this method, this is a function method. What it will do is it will add an element to the set. This has no effect if the element is already present. If you want to add, just add here, add an element to a set. Then if you want to clear, remove all elements from this set. Then copy. Similar to the copy we studied from list, it will return a shallow copy of a set. Then difference, return the difference of two or more sets as a new set. Then similar to all, we have intersection also. Intersection update, each subset is there, each superset, everything is written here. What is the meaning of pop here, remove here? What is the difference? Symmetric difference, symmetric difference update, union. So Let's use the first one. Add an element to a set. Okay, so let's use this method. I hope you remember how to use a method in Python. Okay, now there is nothing here. A dot. So we got 10 here. You have to see it carefully. Add an element to a set. This is no effect if the element is already present. So if you try to do once again, then print a, you see, you get this way. Now you add 20. Because you're printing, you want to see, you will not see that. You remember when we started, if you print, you will not see the repetition anyway. If you write one by one element, you can repeat. That's a separate thing. So this is a method. All the methods of sets are used this way only. You have to write a dot, then you have to write the method, then you can add one element here. Now I will list this way. Suppose I want to add, instead of one element, I want to add a tuple. Will it work? What is the meaning of element here? See, there is a error. Okay, unhashable type list. So you can't add this. Now check with string. Now there is no problem. Then try with a number. Number already we tried. You try with a tuple. If you see the length of this set, you will get 1, 2, 3. So the length is 3 here. Again, let me go back to, it's not 1, 2, 3, 4, 5, because this is considered 1 here. This is 1, this is 1, and this is 1. 1 in a set. If I write a list here, if you remember, we got the error. What it says? Just remember, unhashable type list. List is not hashable. Why they say this way? If you want to know, you need to study what is hashing in Python. We'll go to that later, remember. But you can't have any mutable type here, because normally sets are the keys of dictionaries, and in keys we allow only mutable objects, sorry, immutable objects. So because this is mutable, this is not allowed. It will create problem. You will be able to know in the next class why you can take keys. I mean, list says keys in a dictionary, but just remember, you can't add any mutable type here. Even dictionary is mutable. What about sets? Is it allowed? No, sets are mutable. Sets are also mutable. Not allowed. Yeah, this is fine. Now, can you print, suppose, 2 here? What it says? Set object is not subscriptable. There is no subscript. You can print elements this way because this is not a not a0, this is not a1, this is not a2. Had it been a2, it would have been a20, a21, a22. Because it's not ordered, also it's not indexed. I've written here, they are not ordered, not indexed also. We can add, it's not indexed. There is no such indexing here. So you can't use index. Then how can you print? If you see the other kind of for loop here, that will fail. I've written this one for I in a. If you remember, there is another kind of for loop. I can't use that here. For I in range, whatever number of elements you think, you try to print 3 elements. Print a I. If you write this, will it work? There is a problem. This kind of for loop will not work here. There is nothing called a naught, a1, a2. So no indexing in for loop. So these kind of for loops you can't use here. That means what? This is not a sequence. This is not a sequence. You write it here, not a sequence. Indexing not allowed. Indexing not allowed will not write. It's not a sequence. That's all. So if you want to get access to the elements, you can use this way. And you can use a for loop. If this A you are writing, this A must be, remember, it's very important. This A must be iterable. Any iterable you write, you can apply these kind of for loops for all kind of iterables. And fortunately, set is a iterable. That means what are the all iterables we know by now? String is iterable. You can use these kind of for loops in strings. Tuple is an iterable. Set is iterable. Dictionary iterable. So A can be a dictionary, it can be a set, it can be a tuple, it can be a list, it can be a string also, str. So all are iterable. These are the containers in Python. Okay, now let me write A is 10, 20. And then one more, 30. Then you write B is 30, 40, 50. Then you can write A dot union this way, A union B. So if you want to find A union B, here you have 10, 20, 30, 30, 40, 50, you write everything without repetition. So that is A union B. You can write A dot intersection B. If you write this, then you will get only one. If you want to see all, you write print here. See, this is the union, this is intersection. Then A difference B. Ten 20. A difference B means A minus B. Minus B means everything of B will go along with the elements which are common to A. So you get A minus B. You can check B minus A as well. So, sorry, Control Z. You copy this, then you write here B difference A. If you take the union of this, you will get symmetric difference. Print M union N. Yeah, there is a problem. Will not try. Non-type has no attribute union. What we have done here? Okay, this is the problem. Even the problem will be here. Print M. It's non-type. I'll show you why whenever you write a difference B, when you find difference A difference B here, you will get in D, right? See, what it will do is return the difference of two or more sets as of a new set. All the elements that are in this set were not in the other set. So it will return the difference. Return means it will give something. Now you go back to this. When you wrote here A difference B, then you get this one here. But before writing the print, this is not required anyway. Before writing print, if you take A here and N here, then print Mn, you will get the same thing. Print M. Now you check. A difference B. Maybe some other problem. Now A difference B, not only you are finding, because automatically it returns that we print. If you take a variable M here, then print that variable, you will get this. Okay. So what we want here, M union N. So you write this way, M union N. You run it. We got it. So what is M here? A minus B. What is N here? B minus A. So A minus B union B minus A. You remember here? See, this is A minus B. The elements which are not common to A and B, also which are not in B. So that comes here. B minus A this side. So A minus B union B minus A I found. That is symmetric difference. If you don't want to do this way, then directly you can use symmetric difference. From here only you could have used symmetric difference. A dot symmetric difference. You are not supposed to remember everything. Whatever we use normally, if there is a problem, you can always check. See, there is a problem again. Set object is no attribute symmetric difference. Okay. It says symmetric difference. Okay. Hmm. Symmetric. Dot symmetric difference be. Okay. Let's go here. Where is symmetric difference? Sometimes we have different kind of uh, like underscore and all. Yes, symmetric difference underscore is there. So you write underscore, then you get this 10, 20, 40, 50. Not in the same order, but yeah, they are the same. Even if you want, I can write this 10, 20, then B 20, 10. Then you check A is equal to B or not. Can you check this way? It's true, but you make it a list. False. This is not same as this because the first element is 10, second element is 20. They are not same. Element by element, they are not same. Here, there is no ordering. That's how they are the same. Anyway, now let's do something else. Suppose I write A is equal to so you can't print the first element saying A0. That's not possible anyway. Now, is it immutable? That is the question. Anyway, you can't write this. This is even wrong. I can write an assignment statement like this. I can't change this way because set doesn't support item assignment. There is nothing called a not here. That's the problem. Unlike tuple, this is mutable. This is mutable. Mutable means what? You can't assign one element here. However, this is mutable. Let me run this one and clear. If I go back here, if you check this one, I added a tuple here. That's possible. So I added 10. So if I printed, I got this way. So that means you can change. That's how it's mutable. You can do this. You can add one element. Try doing the same in tuple. It will not be possible. However, remember, nested sets are not allowed. You can't write a set here. You can't add with a set. You can remove. There is a remove method. Okay. Let me write that. Suppose A is this, and I will write A dot remove one element. If it will not work, we'll check the help function, not a problem. Then print a, yeah, 10 is no more here. Then there is another method you can check discard, the same thing, right? Suppose I write 100. 100 you discard here. 40, 10. Okay, 10, 100 is not here. So discard means 100 is anywhere not here. So 10 comes here and 100 is not here. So the same you get. But if you write remove here, it will create problem because it will say it's not present. Okay. The error 100 is not present. How can we remove 100 from this set? But discard means even if it's not there, it will not show error. That's the difference. It will not show the error. Now, if you can do something like this, that means you are removing elements, you're adding elements. So that way it's mutable. Now, the next one is copy the same. Then you write B, the two elements. And you can check whether B is a subset of A or not. B is subset. It's true. It will give true or false. If you write here Boolean type, you can check how you get 1060. Okay. So these are certain things will not use frequently further. So one time if you know, that's fine. Now in a set, what I can write? What are the elements of a set? It's not necessary that you write 5, 7, 8 that way. I can write even strings, Amit, Ramit, Rachit. I can write these names. Is it a set? That's the question. So this is also a set. Now suppose I will change it to 10. Will it work? Yeah, it works. There is no problem. We'll write here only. So I got this, but not in the order. Now suppose I will make it a tuple. Or even a list here. Check, is it possible? Can I write a set like this? Yeah, this is important. We've already seen this one before, but while making a set also you need to know. The elements can't be mutable type. Again, I'm repeating. I'm not going to hashing here, but remember, you can't write a mutable thing here. So you can use tuple here. You can use, this is not hashable, right? Because set is also mutable. You can write set. You are able to write This because this is a string. String are immutable. So you can make it a set as well. A set within a set. That's even not a possibility. Now, anyway, we'll go back. Yeah, this is fine. Print ID of S. Print ID of S not. Again, there is a problem because there is nothing called S not. You can't print this way ID because S not is not there. So you can't get the ID, remember. So up to this, it's fine. You can see the ID. Now suppose I have 10, 20. The ID is already there. Now it's mutable. Mutable means you try to change one element here. Then what will happen? So when you change one element here, suppose I will make it only 10. Then you see here we have a different ID, right? So the same ID we didn't get. Now suppose here this one is there. Suppose I write it 30. This one anyway different. That was not the question even. So what I wanted to say exactly is this is a set already. This is fine. You have an ID. Because if you do time and again, you will get different. Okay, that's how. So this is a set. This is a set and this is the ID. Now set as a whole is like a list. Like a list, when I say list is ordered, I mean list. In list you can get access to the elements by index, here not. So in that way it's not like a list. It's mutable. List is mutable. This is mutable. But if you have a tuple within the list, the tuple is not mutable. This tuple, this is not mutable. That's what. What I want to say is, suppose this one, now what we can write here. So set, when I write, let me write a list here. I get this. That's fine. Then I'm getting a set. If I take a tuple here, can I get a set? Yeah, that's possible. If I write a set here, possible. Again, see, unhashable type. That's why it's not possible. What is the difference between this and this? Here, this set we want to create. In this set, we have a set. That's not possible. It can be an element. That's the problem. you can write this, because what will happen is the elements are 10 and 20. Okay, that you need to remember. So this is possible. So any iterable you can write here. So here any iterable you can write and you can get a set. That way, one way is directly you can write, otherwise you can do this way also. Even you, if you want to write a list here, it will be a list. So within parentheses, if you have written a set here or any iterable, you write the corresponding list or set or tuple, then you write a iterable here, then it will change to this type. Okay, this is a property. Remember, this will be useful later. Next comes to frozen sets. Suppose instead of writing set this, let me go here. I had this, so I'll do this one to frozen set. This is immutable. Now this frozen set is immutable. The type is frozen set. We don't use frozen sets frequently. We can do a bit more here also, but that's not required. We don't use sets frequently, so I don't want to extend and I want to bring a whole lot of things here. This much is sufficient for sets. Class is over now. Thank you.